In this video, we're going to go through some of the calculations required for the gravimetric analysis pre-lab. So number 4 is going to be the first question that we're going to go through. It says to write the molecular equation, including the states of matter for a calcium chloride solution being added to the metal carbonate solution. We need to represent the unknown metal carbonate with M2CO3. So I've already written out the left-hand side of our reaction, the reactant side, and we need to do the product side. So if you look at this, this is a double replacement reaction. And if you recall, when we do a double replacement reaction, we need to list out all of the ions. So we have calcium, we have chlorine, we have our unknown metal, and we have carbonate, CO3. So if I look on the periodic table, calcium's in group 2, so it's going to be +2. Chlorine's in group 7, it's going to be -1. Carbonate, you'd have to look up on your table of polyatomics, it is -2. Now, our metal represents either lithium, which is a group 1 metal, sodium, which is a group 1 metal, or potassium, which is a group 1 metal. All of those have a charge of +1. So our unknown metal is going to be +1. When we do our double replacement reaction, we just draw an X here, and I'm going to write out the left-hand side of my the right-hand side of my reaction. So we're going to have calcium and carbonate. They're going to go together. And then we're going to have MCl. We want to make sure we balance this. The only thing we need to do to balance this is to add a 2 in front of our MCl. Because I have 2 of my metals on the right side. Sorry, 2 of my metals on the left side, and I have 2 of my chlorines on the left side. So I just need to throw a 2 in front right there to balance that. We also want our states of matter. So if you go and look on this table, this has all of the solubility rules for the elements in our, or the ions in our equation. So you would just need to check this table. And if you do that, you will find out that, let me go back to my document here. Everything's aqueous except our calcium carbonate. So this will be, this will be aqueous. And this will be aqueous. I said this would be a solid. I need to get more coffee. Oof, not off to a good start here. Okay, so there is our molecular equation. Next, we're going to do our net ionic equation. And if you recall, when we write our ionic equation, we start by writing our total ionic equation. Anything that's aqueous, we split up into its ions. So I'm going to do that first. So calcium is going to be a +2 charge. Oof. Gotta get more coffee. That's aqueous. I have 2 chlorines. That 2 comes out in front. We have our unknown metal. And our carbonate. Okay, on the right-hand side, we have a solid. We don't split up the solid, so it's just going to be calcium carbonate. And then we'll have 2 of our metals. And then 2 of our chlorines. So that's our total ionic equation. Anything that exists on both sides, we can eliminate from our total ionic equation when we write out our net ionic equation. So the metals are going to go away, the chlorine's going to go away, and we write out whatever's left over. So we have calcium. We have carbonate. And we have calcium carbonate. Okay, so we wrote out our molecular, our total ionic, our net ionic. Now let's go down to this data table. Okay, so we have a bunch of information. So we have some information about our unknown metal, and then we have some information about our calcium carbonate. On the right-hand side, the most important pieces of information that we need here are the mass of our metal and the mass of our calcium carbonate. When it says precipitated, that's the solid that forms. So if you recall, in our equation, we have a solid that forms when we react. So we have two things that are aqueous on the reactant side. That means they're dissolved in water. When we mix them together, it clouds up and it becomes a solid. Okay, A says calculate the moles of calcium carbonate. So we have our grams of calcium carbonate, 1.838 grams of calcium carbonate. I'm going to set up our conversion here. Okay, our molar mass is going to go on the bottom here. So this is going to be 100.09 grams of calcium carbonate. That's how many grams are in 1 mole of calcium carbonate. So when I plug this into my calculator, I'm going to divide, because my number is in the denominator, 838 divided by 100.09, and I get, 0.01836. We want to make sure we have 4 sig figs because our given is 4 sig figs. This is going to be moles of calcium carbonate. Okay, now here's the tricky part with gravimetric. We want to know what our metal carbonate is. If I go back up and look at my equation, we just figured out this. We figured out the moles of this. Oops. Let's look at the molecular equation. We figured out the moles of this. We know how many moles of this we have, but I want to know this right here, our unknown metal. And if you look at our equation, with the exception of our MCl on the right-hand side, everything has a coefficient of 1 in front of it. So the ratio of calcium carbonate to our unknown metal is 1:1. So for every 1 mole of calcium carbonate, I need 1 mole of our metal carbonate. So we're going to use what's called a mole ratio here to convert. So we start with our given, which is 0.01836. We start with the number of moles of our calcium carbonate that we have. And for every 1 mole of calcium carbonate, we have 1 mole of our metal. So we're going to get the same number, but we're changing over to units of our metal carbonate. Oh, I know this step seems a little silly, but it's important to show where this came from. Okay. Next, we're going to calculate the molar mass of our unknown metal. And if you recall, the units of molar mass are grams per mole, which would be the same as grams over moles. We just found the moles of our metal, and up in our data table, we have our our grams of the metal. So we're just going to divide. So 1.972 grams of our metal divided by the number of moles that we have, which is 0.01836. So I'm going to go ahead and divide here. And I get 107.4 grams per mole. Okay, now what do I do with that? Well, the whole purpose of this lab is to identify what our unknown metal is. And there are 3 possibilities. So earlier, you are supposed to calculate the molar masses. You're going to have to do that on your own. So you're going to calculate these 3 molar masses. The number that we just got down here for our molar mass should match up to one of these. It's not going to be the same number, but it's going to be close. So once you have your experimental molar mass, you want to go back to number 3 and you want to find out which one's the closest. This is going to be our theoretical. So whatever one you decide, so let's say it's potassium. So whatever the number is for potassium carbonate, that would be my theoretical. And then down here, this is going to be our experimental value. So D would list out which one was the best match. And then for E, you're going to calculate your percent error. So again, our experimental is the one that we calculate in part C. Our theoretical is what we calculated in part our number 3. Okay, so you're gonna find the difference between them, divide by the theoretical, and then the important part is these vertical bars right here mean an absolute value. You're gonna take the absolute value, which converts any number to a positive number. So if it's positive, it will be positive. If it's negative, it will be positive. So just eliminate any negative sign in your answer and then multiply by 100. And that's it. That's the pre-lab. Good luck and have fun.